Welcome to AI Frontiers, where we explore the cutting-edge research shaping our artificial future. Today we're examining 15 groundbreaking papers that reveal a fascinating truth. We're not just making AI smarter, we're discovering that artificial intelligence might think in ways that are fundamentally alien to human cognition. Picture AI systems achieving human-level performance while using completely different mental processes, safety challenges emerging in household AI agents, and breakthrough methods for detecting harmful content. We're also exploring new frameworks for explainable AI decision-making and witnessing the emergence of AI systems that can actually improve other AI systems. Our journey today takes us through AI's cognitive frontier, where we'll uncover 6 major research themes that are actively shaping the future of artificial intelligence. We'll examine critical findings about how AI versus human decision-making processes differ in unexpected ways, investigate concerning safety gaps that have been discovered in current vision language models, and explore breakthrough approaches to harmful content detection that are revolutionizing organizational research. Perhaps most intriguingly, we'll witness the emergence of AI for AI systems, where artificial intelligence is being used to autonomously develop and improve other AI systems. The computer science artificial intelligence domain, commonly known as CS.AI, represents the laboratory where scientists are attempting to crack the code of intelligence itself. This interdisciplinary field combines computer science with psychology and neuroscience, creating the foundation for technologies we use daily, including voice assistants, recommendation systems, and autonomous vehicles. What makes this field particularly fascinating is how it bridges theoretical algorithms with practical applications, addressing fundamental questions about intelligence and reasoning, while developing safe, interpretable AI systems that can operate effectively in our complex world. The first major theme, emerging from our research, focuses on explainable AI, specifically making black box systems transparent to build trust through understanding. Shea and colleagues investigate how different explanation styles affect human decision-making in predictive process monitoring, while Sadowski and team propose structured prompting frameworks for rule-based decisions. Their research reveals that different explanation methods dramatically impact how effectively humans can work with AI systems. This work is critical for maintaining user trust and enabling proper oversight, becoming essential as AI systems become more powerful and autonomous in their operations. AI safety has evolved from theoretical concern to urgent reality, focusing on ensuring AI systems operate safely in real-world environments. Liu and colleagues introduce IS-Bench, a comprehensive benchmark for evaluating interactive safety in vision language models. Their findings reveal that current state-of-the-art models, including GPT-4o and Gemini 2.5 series, show alarming safety weaknesses. These household AI agents struggle with emergent risk recognition, highlighting a critical gap between AI capabilities and safety awareness. The research demonstrates that safety evaluation must consider dynamic, real-world environments where AI actions have tangible consequences. Human-AI collaboration represents our third theme, addressing how humans and AI systems can work together as what might be described as alien colleagues with fundamentally different cognitive architectures. Li and colleagues reveal that large language models achieve near-optimal decision-making performance while using completely different processes than humans. This discovery suggests AI systems are like brilliant, but alien colleagues with unique strengths that complement rather than replace human capabilities. Understanding these cognitive differences is crucial for effective partnership and has significant implications for AI deployment in decision-critical applications. Advanced architectures represent the fourth theme, focusing on the emergence of AI for AI systems, where artificial intelligence builds better artificial intelligence. Liu and colleagues present ML Master, featuring selective memory mechanisms that integrate exploration and reasoning capabilities. This system represents AI agents that can autonomously improve other AI systems, achieving a remarkable 29.3% improvement in machine learning engineering tasks. This work represents a significant step toward truly autonomous AI development, where systems can independently optimize and enhance their own capabilities and those of other AI systems. Across the research landscape, 5 critical insights emerge that fundamentally challenge our understanding of AI capabilities. First, large language models achieve optimal performance using non-human cognitive processes. Second, state-of-the-art models show concerning interactive safety gaps in real-world environments. Third, ELO rating systems dramatically improve harmful content detection capabilities. Fourth, AI agents require 1.4 to 2.7 times more steps than optimal solutions to complete tasks. Finally, graph neural networks achieve up to 36.6% improvement in optimization tasks, demonstrating the power of relationship-based learning approaches. The methodological innovations driving this progress employ sophisticated approaches for increasingly complex challenges. Large language model integration with symbolic reasoning combines neural capabilities with logical consistency. Graph-based learning enables complex relationship modeling that traditional approaches cannot capture. Benchmark-driven evaluation provides standardized assessment frameworks for fair comparison. Bayesian methods offer principled uncertainty quantification for safety-critical applications. Human-centered experimental design ensures real-world validation of AI system performance, creating a comprehensive toolkit for advancing AI research. Ahmed and colleagues address a fascinating paradox in their work on advancing harmful content detection in organizational research. The challenge involves AI safety mechanisms interfering with legitimate research purposes, creating a catch-22 where systems designed to prevent harmful content analysis also prevent important discrimination research. Their solution adapts the ELO rating system, originally developed for chess rankings, to create competitive content evaluation frameworks. This approach outperforms traditional methods in microaggression detection, while enabling workplace harassment analysis without safety conflicts, proving critical for organizational inclusion and discrimination research initiatives. Lee and colleagues reveal the alien mind paradox in their comprehensive comparison of large language model and human decision-making across three critical dimensions: uncertainty management, risk assessment, and cognitive flexibility. Their research demonstrates that LLMs achieve superior performance while employing fundamentally different processes than humans. This discovery challenges basic assumptions about AI, serving as direct human judgment replacements. The implications for deployment in decision-critical applications are profound, highlighting the urgent need for process-aware evaluation frameworks that assess not just outcomes, but the reasoning pathways that produce those outcomes. Leo and colleagues present ML Master as the master craftsman of AI, introducing selectively scoped memory mechanisms for AI agent improvement. This innovative system integrates parallel exploration with analytical reasoning, achieving an impressive 29.3% medal rate on machine learning engineering tasks. The approach addresses context limitation problems that plague large language models by intelligently filtering and organizing information. This work represents a significant step toward autonomous AI system development, where artificial intelligence can independently design, optimize, and deploy other AI systems without human intervention. Looking toward the future, several critical paths emerge for AI research advancement. Developing process-aware evaluation frameworks that go beyond simple performance metrics becomes essential for understanding AI decision-making. Bridging the gap between AI capabilities and safety awareness requires new approaches to risk assessment and mitigation. Creating effective frameworks for human-AI collaboration must account for fundamental cognitive differences. Advancing AI for AI systems toward full autonomy represents an ambitious but achievable goal. Finally, ensuring explainable AI scales appropriately with increasing system complexity remains crucial for maintaining trust and oversight. This presentation demonstrates the power of AI synthesis and collaborative intelligence. The content was synthesized using GPT and Anthropic Claude Sonnet 4 models, with TTS synthesis powered by Deepgram technology and image generation, utilizing OpenAI capabilities. The entire presentation was reviewed by human AI research experts to ensure accuracy and clarity. While we strive for comprehensive coverage, potential oversights may exist, which is why all original research references are provided for your independent verification and deeper exploration. Thank you for joining us on AI Frontiers, where we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead of the curve. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed with daily insights into cutting-edge developments. Thanks for listening. If you enjoyed this episode, subscribe to our YouTube channel for weekly research updates and join our community of AI researchers and enthusiasts. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archive preprint server.